Okay, we have a lot to cover today. And we're talking about the origins of the universe and of life. And this isn't in your outline. I'm going to throw these next two slides in there because you have a Bible somewhere. And it's from Romans 1:18 to 20. These are my life verses, by the way. Paul says that the wrath of God is being revealed from heaven against all the godlessness and wickedness of men who suppress the truth by their wickedness. Yes?
Do you have another one of these?
Michelle? Remember when I just asked John if he could make a
Oh,
copy?
Yeah.
I thought that was for the other thing. Okay, never mind.
Yeah, that's
I
Michelle's.
thought you meant for the other paper, like the second one.
Nope.
Alright, got it. It's mine, guys. Yeah, that is yours.
Okay, so there's something that God is upset about. His wrath is being revealed because there's something that's known that's being suppressed. And he goes on in verse 19, since what may be known about God is plain to them. Why is it plain? Because God has made it plain to them. So there's something that's very plain for all people to see, and God has gone to some lengths to make sure it's plain to everybody. So what is he talking about? Verse 20. For since the creation of the world, God's invisible qualities, his eternal power and divine nature have been understood from what has been made, so that men are without excuse. Well, glad you could finally join us there, Mason.
What's yours?
Even the most committed atheist knows deep down in their heart that there is a God. That's what these verses clearly say. It's evident. It's plain. And everyone is without excuse to the knowledge of the existence of God. I'm going to throw one more thing in here. Just going to talk a little about intelligent design here. You don't have to, if you want to take notes, fine. But first of all, intelligent design is not the latest version of creationism. Intelligent design is an intellectual movement that challenges Darwinism and its dependence on random chaotic process coupled with selection. So that's the negative side, challenging Darwinism. But it's also a scientific research program that investigates the effects of intelligent causes. We can tell when something's been caused by an intelligence. And that becomes very clear, especially when we look at the origin of life section here. It defines what those are. What are intelligent effects of intelligent causes? They are effects of high specificity coupled with extremely small probabilities. So something has to occur just like this, but the probability of things occurring just like that is incredibly, incredibly small. So intelligent design is also a scientific research program. So we're just going to skip winning the lottery. Okay. All right, get to the universe. This is the Tadpole galaxy, and you can't really see it that well on the projected screen, but behind, this is like, you can't even make a notch small enough to depict how small a portion of nighttime sky this is, okay? But they tell us that in the background are 4,000 points of light. Those aren't 4,000 stars. It's 4,000 galaxies. 4,000 galaxies, okay? So you consider that our universe indeed is vast, okay? Now we're going to talk about here what's called a just right universe. That's your first blanks to fill in. In other words, the universe was made just right. Now, first of all, there are certain numerical constants that are fine-tuned parameters of the universe. So the gravity, electromagnetism, and the strong and weak nuclear force. Each of those equations has a constant in it that we have determined through experimentation what those values are. And so they work out in every situation. And each of these, this is just a number, okay? They're extremely fine-tuned, if anything a little to the right or to the left. For instance, the value for the gravitational constant, one guy put it this way: if you were to spread a ruler across the entire width of the universe, and these are all, every inch is a possible value for the gravity constant, you'd have to find one spot where 1 inch represents the only possibility for a workable gravitational constant. Anything else across the rest of the universe, not going to work. Not going to work. Electromagnetism, nuclear forces are similar. There's also an important ratio between the mass of the proton and mass of the electron. Something else to keep in mind is that every proton has the exact same mass and has the exact same charge. And every electron has the exact same mass and the same exact negative charge. And the negative charge on an electron is equal in magnitude to the charge on the proton. How did these things come about? Just through a big explosion in the past. So these are gaseous pillars. Just a little visual illustration here in the M16 galaxy. And notice at the very top of this largest, these are just dust and gas, okay? That's all that stuff is. And some think it's a place where stars could be formed. But if you look at the very top, see that little finger of dust and gas up there, okay? The width of that little finger of dust and gas is the same as the width of our entire solar system. That's a lot of dust and gas. Again, just giving you a picture of how immense our universe is. Now, you're not likely to be able to see it, but this is a photo taken by, I think, one of the Voyager explorers of looking at the Earth from Saturn. Anybody find it? It's right there. This is what caused Carl Sagan to call the Earth a pale blue dot. How could anything that small and insignificant be of any value? Okay. Now, talk a little bit about the universe. Now we'll talk about our solar system. And I forgot to bring my little blow-up planets. Yeah, well, I wouldn't have been able to hang them from the ceiling anyway. This ceiling's a little different, so wouldn't have been able to hang them anyway.
We could use some of these like beach balls.
Although I might have been able to stick them inside there somehow. But anyway.
Just have Jack stand on table.
Well, our distance from the sun, 93 million miles, is just right. If we were 20% closer, all of our water would turn to vapor. If we were 20% farther away, all of our water would turn to ice. So we're in what's called the circumstellar habitable zone. Circumstellar, what's that mean?
What does circum mean?
Spherical.
Okay,
Not quite.
around,
Circle.
Around.
circle.
Stellar.
Star.
Exactly.
So we are in the band of the right distance to be from the sun to allow liquid water to exist. The type of star that we have, our sun, its size, its temperature, the amount of visible light it emits are all just right to support not just life, but complex life here on planet Earth. The moon, very important. Its size, it helps stabilize the tilt for our axis. The rotation of the Earth, much faster, things would fly off much slower, and days and nights would be too long, and things get too hot and too cold. So even the rotation of the Earth is just right to support life. The composition of the Earth means at the center of the planet, they hypothesize, is a core of iron and nickel. And this core is so dense and so hot, being down at the bottom, that some describe it as a liquid iron nickel core because it does circulate. And that circulate is very, very important because it constructs the electromagnetic field that surrounds the Earth to protect us from most of the harmful rays that do come from the sun. So even the composition of the Earth is important. Jupiter and Saturn, very curiously, these two large planets act as sort of like Well, first of all, their orbits, because of their large gravity and their orbits, which are nearly circular, stabilize the orbits of the inner 4 planets, so Mercury, Venus, Earth, and Mars. Without Jupiter and Saturn in place, our orbits would likely be elliptical and in different planes, which would mean we'd run into each other eventually. So keeping those inner 4 planets in near circular orbits is very important, so Jupiter and Saturn accomplish that for us. The other thing they are is they're sort of a comet and asteroid vacuum cleaner. They pull in a lot of comets and vacuum and meteors that would be around that could get into the inner 4 planets and cause a catastrophic impact. Now, it's been guessed from various issues with geology and paleontology that we've probably received a catastrophic impact, I think they've said about every 100 million years or so. And they say this reduces it 1,000-fold. So without Jupiter and Saturn, instead of every 100 million years, but every 100,000 years, we'd be getting a strong impact, okay? So even our our solar system is arranged in just the right way to allow complex life to exist here. Some have questioned whether there could be life on Mars, and that's still something they want to continue to search for. They haven't found any actual evidence of life. But most likely, as one astronomer has theorized, that if we do find evidence of life on Earth, on Mars, it likely came from Earth. Because of some of those early asteroid impacts, it would throw chunks of the Earth out into the atmosphere, and eventually they get going around the sun as well. Some of those could collide with Mars and plant Mars with Earth life. And there you can see Earth in comparison to the sun. It's good that we're 93 million miles away from that giant star. Anybody know how long it takes light to get here from the sun to the Earth? 8 minutes. Tells you something about the distance. Light travels 186,000 meters per second. Oh, miles per second. 180,000 miles per second. So it's got to be quite a ways. And then here you see the relative size of these planets. Jupiter largest, then Saturn, then Uranus and Neptune. By the way, yes?
How long would it take to go to the sun, like a rocket ship or something?
A lot longer.
Very long?
Well, just consider it takes several days just to get to the moon. And if they thought about traveling to Mars, they're saying the flight alone could take a couple of years. And the other problem with going to Mars, however, is that you're not coming back. There's no way they'd be able to store sufficient fuel to get you back to Earth. So it's a one-way trip. So that's going to take a couple of years. So getting to the sun would also probably take decades, I would think. But of course, the closer you get to the sun, the heat intensifies and the gravity intensifies, and you're not going to last long anyway.
And it doesn't work to just go at night.
That was my second question.
That's why she doesn't say much during my science classes. We get comments like that. Okay. Now, the last one there is Pluto, but Pluto's been kicked out of the family, technically. It's referred to now as a dwarf planet, not an actual planet. They have found another one slightly larger than Pluto that's further out. And the other reason is because all the other 8 planets are basically revolving around the sun in the same plane. Pluto does not. It's askew. Okay?
Is there one that's like just a little bigger than Pluto? Is he also in our solar system?
Yeah.
Oh.
It revolves a little further out. Okay. Now, we're going to be dealing with some big and small numbers here in a little bit, and I know you guys have all taken math here, but when I do this with general audiences, for most of them, if they never saw another math number again in their lives apart from money, they'd be just as happy. So, exponents. 10 to the first power means 10. 10 to the ninth power That's 1 billion, okay? 10 to the minus 1, well, that's 1/10. 10 to the minus 9 is 1/1 billionth, okay? So just try to keep the idea in your head. Hopefully it's been recent enough for your math classes to remember all that stuff. So, the astronomer Hugh Ross has been accumulating a total of some of these fine-tuned parameters. I just went through a handful of them, okay? He says now that there are about 860 of these finely tuned parameters. And the probability of all of them occurring by chance, see, each of the parameters themselves has a probability of occurring by chance. And you just multiply all those probabilities together. When you do that, you get this number, 10 to the minus 1054. Or, there you go.
Keep going.
Chance of all, not yet. Oh,
I'll say or.
Whoa. That was a cool transition. And then it just kind of hits you with O's. There's O's. There's a lot of donuts.
all those zeros.
Those zeros.
There's no O's up there except in probability and or. Okay, pretty small number. But I've also indicated that we have an enormous number of galaxies. And we've actually tried to estimate how many possible stars there are in the universe in all these estimated galaxies. And it's estimated there's about 10 to the 23rd stars. Okay? So, how many stars or planets do we have? Well, basically, we're told about 10 to the 22nd, which is very close, interestingly, to Avogadro's number, if you're familiar with that. And let's just assume that on average, each star has one planet. Now we know ours has 8 or 9, and we've started to find some what are called exoplanets, planets that are revolving around other stars. Those are very difficult to detect. We don't actually see the actual planets. We find a darkening of the star as a planet moves between it and the Earth. That's how we detect them. So, how many planets could be suitable for life? Well, 10 to the minus 1054 times 10 to the 22nd, or 10 to the minus 1032, or that many planets suitable for life in the entire universe. Now, we just happen to be the one that broke the odds, okay? What do you think, how would you calculate the probability for there being a second planet that would be suitable for life by chance? How would you calculate that? Well, essentially you would take this number here and square it. When you do that, you get 10 to the minus 2064th. These are impossible probabilities, okay? All right. So, Robert Jastrow, quite a few number of years ago, wrote a book called God and the Astronomers. And what he was charting was how astronomers were responding to this idea of a Big Bang and the fact that the universe had a beginning, okay? As we survey all the evidence, the thought insistently arises that some supernatural agency must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of a supreme being? Now, when he says it's not what we were looking for, suddenly, without intending to, they had assumed in the early 20th century, early 1900s, that the universe has been around for eternity. No beginning, no end. But then we began finding these evidence of a Big Bang and a beginning. Many astronomers were rejecting the Big Bang not because of the scientific issues, but because of their philosophical disagreements. As Robert Griffith said, if we need an atheist for a debate, I go to the philosophy department. The physics department isn't much use, because they see all that evidence for the existence of a supreme being. So what are we learning about God here so far? Well, first of all, he's loving and caring because he's arranged this entire universe, this entire solar system, everything about this planet. The fact that we have 21% oxygen and 78% nitrogen. Nitrogen is very important. It's a neutral gas, and it also helps break up ultraviolet rays or gamma rays. So God's loving and care, he put together this entire universe just for us. Also, God is omnipotent. He simply spoke, and these things came into being. And also, God is eternal. Now, we went over this in the existence of God talk, but the reason we can say this is because something has to be eternal. Remember when we talked about that? If the physical universe is not eternal, then something else has to be eternal. Because there has to be what they call an uncaused cause. The universe isn't it. So it has to be something outside the universe. How we doing? Still with me?
Yes.
Wasn't loud enough. Oh, a little while. Back row could hear it this time. Okay. All right. Now the origin of life. So we've covered origin of the universe here in these first 25 minutes or so. And this one gets a little bit more involved. A little bit more chemistry. You've all had, one hasn't had chemistry here yet, right? Two haven't had chemistry. Pre-chemistry. Okay. Okay. There's been research into about how life could have arisen without outside interference, no intelligence, whatever. There's a famous experiment. Stanley Miller and Harold Urey performed these experiments in the early 1950s, and we'll get to what they did here. What Miller did was he mixed ammonia, methane, water, and hydrogen gases. And then he introduced sparks to simulate lightning. And he produced many organic compounds plus a few amino acids. That was the only biological compound that came out of it, a few amino acids. I love this cartoon. If I can just synthesize life here, then I'll have proven that no intelligence was necessary to form life in the beginning. That's a joke. He doesn't have intelligence. Can you tell? Not really. Oh, it took a while.
That's a good one.
Made me laugh because we laughed.
Oh dear. Okay, so in what you see there is a diagram of the Miller-Urey apparatus, okay? And what they were doing here is they put water in here, and they boiled the water to create water vapor that would obviously go up through this tubing. And here, the mixture of gases would be the methane, ammonia, and hydrogen would be brought in with the water vapor. So now you have all four. And so the circulation continues, then there'd be this little sparking chamber, okay? And then the flow would continue around, and it would come through here, what's called a condenser. There would be cool water siphoning through there the whole time that would cause the water vapor to turn into liquid water. And then they had a little trap down here, and they were able to collect the things that were made in their experiment. Now the first thing you had to realize, there could be no oxygen here. Why not? What is methane? Where do we use methane all the time? It's natural gas. Natural gas. No, not cars. It's natural gas. So if you have a gas stove, you have gas appliances, that's methane, okay? And, well, if you put oxygen in this atmosphere, what would happen in that spark chamber? Kaboom! Yeah, so there can't be any oxygen available. And I would be willing to guess that they were using distilled water as their water source. And the reactants, methane, ammonia, hydrogen gas, they were purchasing from chemical supply companies. So they would be very, very pure. No such situation could occur on the early Earth. There'd be all sorts of other gases mixing around and complicating all these reactions. Now there are some problems here. First of all, the breakup of these early Earth gases, particularly methane, ammonia, and water. With ammonia, when that is hit by ultraviolet light, it breaks the ammonia down into nitrogen gas and hydrogen gas. If there was ammonia in the early Earth atmosphere, it would disappear within a few thousand years. It'd all be gone. Well, methane is a little different. It doesn't get broken up, but ultraviolet light causes it to polymerize. So you get CH4, eventually you get butane, C4H10, and just longer and longer flammable liquids would form, and they would eventually fall to the surface of the Earth, and all the methane would be gone again within a few thousand years. Now I've got all this dangerous flammable liquids floating around on the surface of the oceans. We've had no evidence of that. So early Earth gases would disappear. There are lots of energy sources that would be available, not just lightning. Also, a spark doesn't really simulate lightning very well. I mean, lightning basically fries everything nearby. Okay? And there'd be shock waves, there'd be thermal heat waves, and all sorts of things up in this early atmosphere, not just sparking. You probably have lots of gamma rays and X-rays and ultraviolet light coming from the sun that would destroy all these things before they ever were. So that all these things would be broken down before they ever reach the surface of the Earth or reach the ocean or still small pond. The other complication here is that even if amino acids were made, sugars were made, nucleotides were made, and fatty acids were made, once they come down to the surface of the Earth, they all mix together. You're not going to be able to get a pure collection of amino acids to make proteins. You're not getting a pure group of glucose molecules just to make carbohydrates. That's not going to happen. So all this stuff mixes together. And they will react with each other just as readily as they react with their own type of molecule. So this would be another dead end. So we're seeing dead ends of not pure reactants to start with. We're seeing dead ends of many of these molecules breaking up within a few thousand years. We're seeing a dead end with those things that are formed getting to the surface of the Earth that just mix with everything else and they react with everything else. You're not going to get a chance to get life molecules. So the presence of oxygen. This is where ultraviolet light comes into play again. When ultraviolet light hits water, it breaks it up into hydrogen gas and oxygen gas. So if you have UV light and you have water vapor, every scenario has water vapor, you're going to have some continuous supply of oxygen. Now the oxygen can get used up in other sorts of things, but there's always going to be some oxygen in your atmosphere. And for the most part, what's been called the reducing atmosphere has been replaced, usually kind of using something like carbon dioxide and of course water, nitrates, nitrites for some nitrogen, but those are far less reactive reagents than the earlier ones here were. And in the book, The Mystery of Life's Origin, Drs. Bradley, Olson, and Thaxton kind of summarize things this way. Furthermore, no geological evidence indicates an organic soup, even a small organic pond, ever existed on this planet. We may, with fairness, call this scenario the myth of the prebiotic soup. There never was any such thing. Now the other problem here, let's just say you could get all the proteins. You got carbohydrates, you've got DNA, you've got RNA. How does all this work to compose a cell? Well, we have some problems here. If you come up with random molecules, we have machines and we input energy, usually through electricity, and we can create much more order on the other side. Let's just say you have a machine that makes shirts. So you put in the cloth, the thread, the buttons, and everything is designed a certain way to construct a shirt. So you put in these random building blocks, and out the end comes a much more ordered and specific garment. Life does much the same thing. Living cells take in, they take in food, take it in lots of different ways, but that food right there, like in itself, does you no good. But the cell has energy, it has machinery, which is able to break down all that food and turn it into energy that it needs, also to build the proteins, carbohydrates, nucleotides that the cell needs. So that's how we go from randomness to order. But if you just add energy, and it's not directed energy, it's not being introduced into a machine or a cell, which is full of nano machines, all you're going to get is more randomness. Raw energy alone just makes things worse. So even on the early Earth, if you're depending upon energy from the sun to take all these great biological molecules and order them into a living cell, I'm sorry, it's not going to work. Somehow that energy has to be channeled in just the right way. So I brought my friend Fred along here. Fred's got a problem, which is the black cloud over his head. He's got this really tall grass to mow, and all he's got is one of these ancient push mowers.
Those are so hard to use.
Takes a lot of effort to use an old-fashioned push mower. But Fred's Homo sapiens, he gets an idea. I just need to add some energy to my system. So he goes in his garage, gets his can of gasoline, and pours gasoline onto his lawnmower. Well, all Fred's got is a smelly lawnmower. That energy is not doing anything. Then Fred has a second idea. He needs to release that energy. Oh. Didn't work so well that way either. Undirected energy is just going to make everything worse. Now, some of the grass did get lower, it just got burned, okay? He has a third idea. Fred realizes that what he needs is a motor that burns the gasoline slowly and in a designed sort of way that turns the wheels, that turns the blades, that cuts the grass.
Third time's the charm.
Huh?
Third time's the charm.
Mm-hmm.
It's probably many steps.
Yeah.
Who cares?
Like, good idea.
Let's put like a long process together.
Yeah, to get to the motor, right.
He's really made it accomplishment.
Especially if you start with gas.
Yeah.
Yeah.
So all this is simply to illustrate, if you have undirected energy entering your system, it's not going to improve things. It's going to make it worse. Energy has to be channeled in a very specific way, at a very specific rate, not too much, not too little. If you've ever had to deal with a lawnmower that was sputtering most of the time, well, it's kind of hard to get much done with a sputtering lawnmower. Yeah, you've got gas, it's burning gas, but it's not, the engine is not functioning properly, and so things take a lot longer. So, this brings us to the origin of biological information. When I say biological information, what do you think I mean? DNA? And what kind of information does DNA contain? Biological? Yeah, can you be a little more specific? What does the DNA code for?
Life.
No, yes, sorta. The DNA contains the code to make specific proteins that the cell needs. Anybody remember what the process of protein synthesis is? DNA is transcribed into RNA. RNA is translated into protein.
Biology.
Huh?
Biology.
Biology. Well, yeah, you should all love that. I mean, right? I taught some of you people biology here, so come on. Been too long, huh, Jack? All right, so what we know about information, first of all, chaos, as we saw with Fred, does not give rise to order. When everything just blew up, that was chaos. And the same way with information, noise does not give rise to information. Things have to be organized. Just like with Fred, he had to have an organized motor attached to the lawnmower in just the right way to make the process of mowing the grass much easier. Now, let's just say, in the old style radio, it actually had to turn the knob dial. Anybody still familiar with any of those?
Oh, we got those on the cars, yeah.
Change stations. Not anymore.
Well,
My car doesn't have any of that.
we got a 2004 on those.
Okay. Well, there used to be a knob to change stations, right? When you're changing it between stations, what do you hear? Static. It's just noise. It's noise, right? Let's just say you deliberately turn the radio to between stations and you're getting the static, and you basically say, well, given enough time, Beethoven's Fifth Symphony will just suddenly arise out of the static.
Obviously.
Have any takers on that bet? Couple days. Well, obviously it's not going to happen. Information noise is not the same thing. So, origin of biological information. What you see here are obviously ripples in the sand, and that's a fairly ordered. You got some little ridges here with the ripples, and that's simply due to the movement of water, the properties of the sand itself as to what kind of little ridges you will find. But there's no information in that order. There's nothing, it's just the same repeated ridges and grooves. That's it. There's no information there. But let's say you walk to a different part of a beach and you see this. Now in the background, you see just this is a basalt beach on Oahu, Hawaii, okay? And that's why the blocks and sand are all black. So you see this jumble of rocks in the background, and that's extremely complex. And to try to arrive at that same arrangement of rocks by chance would be nearly impossible, no matter how you went about it. And so you could say, well, maybe there's information there. Well, but it doesn't mean anything. Nobody gets any meaning out of that assemblage of rocks on the beach. But you look in the foreground, it looks like there's a circle of rocks that's been laid out. And there even appears to be a little entryway right here, okay? And then you have some larger rocks that people probably could have more easily sat on. And I don't know, maybe there's 3 to 4 dozen rocks. So a much smaller number. Seems to be in a specific arrangement. Maybe they had a campfire in the middle of it. But we could probably have an interesting discussion / debate about, did that happen by chance or did it have to be arranged by an intelligence? There's not much information there, okay? It's just a circle. It's just a circle of rocks. So we don't know. But let's say you walk a little further down the beach and you see this. I always have to ask, who do you think wrote this, John or Mary?
Not me.
The girls almost always say John wrote it, but anyway. Well, what you see here now is not just a circle of rocks, but you see very precise symbols, are letters of the alphabet. These letters are arranged in a sequence. And they're grouped into words, 3 words, John loves Mary. It communicates a message. The circle of rock communicates no message, okay? This does. And you have to have some very precise symbols. You have to have them grouped together properly. If you put some of those letters out of place, you might not know what they're supposed to say. That's what the jumble cartoons are about. They give you all the letters and you have to arrange them into an actual word. And it takes some time. Word jumbles. Scramble.
Word scramble.
Oh, well, anyway. And when you look at this, however, you don't really know who wrote this message, do you?
I think it was John because Mary would have made the N nicer.
She says she thinks it would. John wrote it because
If she wrote her name that many times, she's not going to write the N like that. So I think it was John.
if it was Mary, she would have written the M nicer.
Yeah, I mean, I think it's hard. Why would, I mean, I think it's, me personally, just me personally, I think John wrote it. I mean, like, that's like saying, person likes me. Other than, I think it would have more meaning if it's like, I like a person. You know what I mean?
Uh-huh.
And it's kind of self-centered. Oh, I guess, well, if it's true, it's not, but it's.
Well, even there, do you know whether this is true or not? No, you have no idea whether it's true. We don't really know who wrote it. Actually, I wrote it, okay? Just you know. Okay. Yeah, I didn't love Ray loved Sue, you know, and he was a previous writer has always used this John Loves Mary thing as his illustration, so I just copied it. But you know an intelligence was necessary to put this in the sand. You had to have an instrument. You had to know how to shape the letters. You had to know, put the letters in the proper sequence, and then group them properly, and then arrange the groups of letters into a sequence that communicates a message. Whether it's true or not doesn't really matter. But you know an intelligence was necessary for this. Now, we're going to go here to comparing our language to biological information here. We use letters from the alphabet to make up our words, and in the DNA, RNA, they use nucleotides. Nucleotides are arranged in a sequence, as letters are arranged in a sequence. We group letters together to make words. We group nucleotides together to make codons. 3 nucleotides make a codon, and each of those codons codes for a specific amino acid. Now we group words together into sentences, and genes could be compared to a sentence, lots of codons in sequence, and sequence of amino acids is what makes a protein. So we're going from letters to words to sentences. Put lots of sentences together, you get a book. You put lots of genes and proteins together, you get a chromosome. You put lots of books together, you get a library. Put chromosomes together, you get a genome. And we're learning more and more about the DNA in our cells. It used to be thought that maybe about 95% of it was junk, not used for anything, just evolutionary leftovers. But over the last 15 or so years, we've been discovering, however, that almost all of that DNA does get transcribed into RNA. The RNA is not translated into protein, but that RNA is performing regulatory functions within the cell, and absolutely necessary. So we're beginning to do experiments where we pull out certain parts of a chromosome. We know there's no gene there, and the individual ends up having difficulty surviving. Not they can't survive, but very, very difficult. And the conclusion we come to here is that DNA informational code requires, I didn't say assisted, I said it requires intelligent pre-programming. It has to be there. When we talk about protein synthesis, said DNA transcribed into RNA, RNA translated into protein. Well, those are language terms. It's not because they're helpful, but they actually describe what's happening. The RNA language is completely different from protein language, and you have to have a translation take place. Now, again, how even something as basic and necessary as that could come about by just chance events, again, your probabilities are extremely, extremely small. And not enough time for it to happen. There's a wonderful organic chemist named James Tour. And he's been on the warpath for about 10 or so years now. as an organic chemist, what he does is he constructs carbon-based molecules. And as he describes it, you think you lay out a path that you think will work. But inevitably, you get to this spot, oh, that's a dead end. We can't get past it. So you have to back up a few steps and then go a different route, and you can get past that roadblock, and you likely will hit another roadblock. You have to back up again, restructure things, and do different processes. And it's just a lot of trial and error. Now he says, on the early Earth, you can't do that. I mean, once you get to the dead end, it stops. You can't back up a few steps and try again going a different route. He's very entertaining, by the way. If you just do a Google search for James Tour, you'll likely come up with either a lecture or a debate he's done. And yeah, he's pretty entertaining. James Tour, T-O-U-R. Now, he'll admit, I'm not saying that we'll never figure this out. But he basically says, right now, we don't have a clue. So what do we know now about God? Well, we talked about him being loving and caring. We talked about him being omnipotent. We talked about him being eternal. And now we know God is intelligent. Extremely, extremely intelligent. And when we get to evolution and origin of complex adaptations, we'll find out that God is quite imaginative as well. You start considering all the different kinds of life forms. Now, thoughts, comments, questions, complaints? I didn't get any of it. Okay.